So it wasn't too hard, but I would definitely encourage you, maybe if you don't understand what we do when we go over this, check it out. Okay, so here's the homework answers from last night. Number 1 was the only one you really had to graph. But then we found all these same answers for the next 4 problems. The asymptote, which we said, of course, you can see that asymptote changing if something happens inside those parentheses, which here they clearly did, x plus 5. So remember, inside is the opposite, so it went left 5. So my asymptote moved to x equals negative 5. Then we said, listen, that's a barrier wall, okay? And I cannot, left and right, I can't go past that. So negative 5 is the restricted part of my domain. Now, it can go to the right forever, so it's from negative 5 to infinity. But up and down, no limits. So negative infinity to positive infinity. And then I told you could find your x-intercept one of 2 really good ways. What were those 2 good ways? Yep, you could graph it and see it on your calculator. And what was the other? You can solve it, because you know what about every x-intercept? What do we say? At every x-intercept, what do you know? Y equals 0. And since the equation says f of x equals, or y equals, you can replace that y with a 0 and solve. So I actually did that on the next 4 examples because I wanted you to see, just because you didn't have a calculator did not mean that you couldn't find the x-intercept. You can, all right? In fact, number 2, you probably would have preferred it. Number 2 was crazy. So here it is. The asymptote on number 2 moved to negative 8, right? X plus 8 inside. So x equals negative 8. That restricted your domain to negative 8 to infinity. Then you've got your range, negative infinity to positive infinity. And then your x-intercept was 248. I mean, kind of big. Sure enough, somebody in my second period, they scrolled down until they found the y value of what? 0. They scrolled until they found the y value of 0, and sure enough, the x value was 248. Did anybody else do that? They're dedicated. I was a dedicated student. So basically, none of y'all were dedicated. No. Unless you solved it, then you're dedicated. Again, so you saved yourself. If you cheated, you're not dedicated. You just copied someone else's answers. All right. Any questions with number 2? All right, here's number 3. Again, your graph has a horizontal shift of 4 to the right. So your asymptote moved to x equals positive 4. That restricts your domain, so 4 to infinity. Your range is unlimited, negative infinity to positive infinity. And then, of course, whether you graph it and look at your x-intercept, whether you look at your table and look for where y equals 0, or whether you set the problem equal to 0 and solve, you should have gotten 5 as your x-intercept. I like to write them as ordered pairs, so 5, 0. Questions about number 3? Okay, here's number 4. This one shifts to the right 2. So my asymptote moved to x equals 2. That restricts my domain. That barrier wall can't go past 2. Now it can go to infinity, so 2 to infinity. Range unlimited. Your x-intercept, again, whether you graph it, look at your table, or solve it, 7. Questions about that one? And number 5, last one of these. You're going to have a couple of these on the quiz tomorrow. Let's move to the left 1. So my asymptote is x equals negative 1, which restricts my domain. Can't go past that asymptote, so negative 1 to infinity. Of course, an unlimited range, up and down, unlimited. And then, of course, it crosses your x-axis at 3, 3, 0. All right? Y'all feel good about this? I should just give you a quiz today, shouldn't I? Nope. And then if y'all didn't do the last 4, that took probably a total amount of time of like 4 seconds to write those. Maybe 10. 4 to 10 seconds. Okay? All right. So y'all ready to go to the review?
Yeah.
Y'all ready to take a quiz?
No. Oh, no.
I can pass out one or the other.
You.
I really can't.
I don't have it copied yet. I haven't made copies.
Actually, yeah, maybe.
What if we had said yes, Mr. Hoskins?
I would have been like, sorry. Wait, don't mind. I haven't even made it yet. I know there's going to be 12 to 15 problems on the quiz. 12 to 15. The first 6 will literally take you 3 seconds. It's those easy, where you have to rewrite one. You'll see. If you forgot that, I'm smacking you in the face. It's the review. What do you think? Are you kidding me? Remember when I got a snack yesterday? How many short was I?
There's 20 questions.
Say, I'm 1 short again. That's unbelievable.
Why is it like 6 months?
6 pages.
How long?
I must have given you a couple of them.
No, you only one.
This ain't 6 pages.
1,
It's
2,
3.
3.
Technically, it's 2 papers.
3 pages. Enough.
Look, now it's 6 pages.
When you flavor water, you have to put spices in it.
What does that mean, spices? What is considered a spice?
Like cinnamon.
Yeah, anything that's flavored with some type of flavoring.
Some of these things I can't even see.
Okay, so we can go through most of this pretty fast, and then we'll get to so for example, here you have 6 problems that should literally take you all of, I don't know, a minute to solve. So when I say that there's 12 to 15 problems of these, I'm going to put 6 of these, just like there's 6 here. I'm going to add one though. I want you all to write log of 1,000 equals 3. We'll do that one in just a second. I meant to put one of those on and I didn't, so there it is. Now, remember, when it comes to rewriting one from a logarithm to an exponent or an exponent to a logarithm, what's the key? What's the key? The base. And then, of course, you do the loop, right? So these seriously should take you no time, and that's almost half of what your test will be. Okay, there'll be 6 of these tomorrow on the quiz. So, how do we rewrite number 1? 36 to the 1/2 equals 6. Done. Number 2. Somebody else, let's go. 2 to the 5th equals 32. The base of your log becomes the base of your exponent, and then you do the loop. 2 to the 5th equals 32. Number 3. Somebody. 4 to the -1st equals 1/4. And I wanted to include one like the top here that I added because I wanted you to remember, when there is no base, it's understood to be base what? It's understood to be base 10. So when I rewrite this, that is 10 to the 3rd equals 1,000. Please don't forget that. So, going from a logarithm to an exponent. You got it? Can you do that? Okay, then let's go the opposite direction. Let's go from an exponent to a logarithm. log base 3 of 1 over 9 equals negative 2. Done. Number 5. Log base 5 of 1 equals 0. Done. And last one, log base 4 of 64 equals 3. That's 6 problems. And more than likely, it'll be probably a 14, 15 problem quiz. So what's 6 out of 15 even?
Almost a half.
I mean, it's not too far from it, is it? And how long did that take?
Maybe a minute.
Okay. Same for the next section of problems. You're going to have 2 of these, just like you have 2 in the review. Now, you don't have to graph them physically on this piece of paper or on the quiz tomorrow, but could you use your graphing calculator for this section? How will it help you? It'll help you with the x-intercept. It could also help you with the asymptote, just to kind of see where this thing moves to. But hopefully, you guys can find the asymptote without the calculator. Remember, inside is your horizontal shift, which affects your vertical asymptote. So guys, what's my new asymptote for this problem? X equals 4. What does that do? It limits my domain. My domain cannot go past 4. But if you graph it, you'll see it goes off to the right forever. What do we say about the range?
It always goes up and down.
It always goes up and down forever. So the last part of this is the part that might take just a little effort. How long did those 3 take? No time, right? So you have a couple of options that I've mentioned. 1, graph it. You could look and see where it crosses the x-axis, or you could go to your table and find where y equals what? 0. Last, you could take log base 3 of x minus 4 minus 1 and set it equal to 0. Those are your options. I don't care which one you do. I just want you to get it right. So if I did it this way, before I can solve this, I've got to move that minus 1. How? Add it. What's 0 plus 1? Positive 1. Hey, Braden, grab one of the reviews right there. Since you've been slacking, skipping class so much.
This?
Yeah, and you'll need those 2 papers from yesterday, skipping and skipping. There you go. You got all your skipping papers.
Wonderful. I'm gonna need some.
There's videos available online.
I'll do those at home tonight.
This one's already recording, so it's getting this.
Oh, wonderful.
You'll get to hear yourself
Well,
talk.
there you
Okay, so here I'm ready to now solve it. So I solved this logarithmic equation by rewriting it as a what? So that's the base of the log becomes the base of my exponent. 3 to what power? Equals. What is 3 to the first power? 3. I'm going to add 4. What's 3 plus 4?
7.
So this thing crosses my x-axis where? At 7, 0. Now, if you graphed it, is that what you found? Did anybody try to graph it? Fine. Solve it. I'm fine with that. Graph it, solve it, do both. Okay, knock yourself out. It's not going to take you that long, is it? Okay, next one. What's the asymptote? X equals negative 2, because it shifted left 2. So that restricts my domain to what? Negative 2. Look at the graph. I promise it goes off to the right forever. What do we say about the range? Unlimited is what we said about the range. And then lastly, Again, I don't care whether you graph it or solve it. I'm going to go ahead and solve it. I'm going to set it equal to 0. I don't have anything to move yet, or at this point, so I solve by rewriting it as a what? Exponent. The base of my log, 4, becomes the base of my exponent, and then I do the loop. 4 to what power? The 0 power equals x plus 2. Now, what is 4 to the 0 power? Yeah, that's the one. And it equals x plus 2. So what's the last thing I do here? And 1 minus 2 is, I promise you, if you graphed it, this thing is crossing the x-axis at -1. Okay? Feel free to check yourself. So that's 8 of the probable 15 problems. That is over half, isn't it? So the last 7, more than likely, will all be from this bottom section where you have to solve. Okay? And there were 4 ways of solving. 2 ways of solving exponential, 2 ways of solving logarithmic. Okay? So let's start with exponential. First, how do I know it's exponential? It has a variable in the exponent. How do I know it's logarithmic? It literally says log. Okay? So, easy to tell. There are 2 types of exponential. We said you could create your bases to be the same. For example, right here on this problem. Can't I make 8 have a base of 2? 2 times 2 is, 4 times 2 is 8. So I could rewrite 8 as 2 to the 3rd, 2 cubed. So 2 to the x plus 5 equals 2 cubed. Again, if I can create the bases to be the same, or if the bases are already the same, what is my simple process of solving? Drop the base. And then you can take what's remaining and set it equal to 0, or each other, and solve. So how do I solve this thing? Subtract 5, so x will equal -2. I'm going to come back to that in just a second. So hold on to that problem a little bit. See, type 2, can I create those to have the same base? No, I cannot. So I don't have an option to do type 1. I have to do type 2. So type 2 is when I can't create my bases to be the same, rewrite it as a logarithm. So log base 5 and then the loop. Log base 5 of what? 38 equals what? X minus 1. Now I hope this doesn't happen with you guys, but Brayton, tomorrow if you call me back to your desk and say, I can't remember where to find log base, what am I going to do? I'm going to turn around and walk back up here and be like, tough luck, Brayton. Please remember where log base 5 of 38 can be typed in. Where is it? Are you kidding me? You don't know where to go?
I was at the calculator thing.
Alpha window 5. Please don't forget that tomorrow. I'm not going to tell you. Seriously. Alpha window 5. We've done that enough. You should know that. So, log base 5 of 38 gives me about 2.26. Is that what y'all got? It should be. So last step, what am I going to do to solve for x? I'm going to add 1. So 3.26 equals x. What would you have rounded that to? 3.3? Yeah, I'm not going to mark it wrong. I like 2 decimals personally, but it's fine. Now, I want to pause for a second, and I want to erase this real quick, and I want to remind you something. I told you guys when y'all learned that method that you would like type 2 better. Here's the point. On type 2, that problem, could I have done type 1? Could I have created 5 and 38 to have the same base? Could I? No. I could not have done type 1 on that second problem. I had to do type 2. Here's the point. Could I have done type 2 on the first problem? Yes. And if you want to, you can. I'm fine with it. Watch. You would simply take log base 2 of 8 and set it equal to x plus 5, just like you did type 2. Okay, type 1, really, you could do either way. Now, log base 2 of 8 is 3. So sure enough, 3 would equal x plus 5. I'm going to subtract 5, just like I did the first time, and x will still equal negative 2. So the point is this. When it comes to having the same base or creating the same base, you really have options. You could use type 1 or type 2. I'm not going to tell you which one you have to use. Now, on the one like number 2, you can't do type 1. You have to do type 2. Okay? So, please remember that. Okay, now, on the logarithmic ones, though, you don't have that option. You either have type 1 or you have type 2. What is type 1? Log equals log. We drop the logs. So I literally just cancel them out, and whatever is left, I solve. So 2x minus 4 will equal 10. We add 4. We divide by 2. Done. But in type 2, we don't have log equals log, so we're going to rewrite it as a what? As an exponent. So I'm going to take the base of log. What's the base of my log here? I'm going to make it the base of my exponent. 5 to what power? Second equals 3x minus 2. What is 5 squared? So 25 will equal 3x minus 2. I'm going to add 2. 27 equals 3x. And then I'm going to divide by 3. So x equals 9. Questions? Y'all feel good about that? Okay, so let's move on. And I'm just going to go pretty quickly through these. In fact, let's knock this out of the way real fast. Exponential or logarithmic on number 9? Exponential. Number 10. Logarithmic. Number 11. Logarithmic. See, you see the word log. Number 12. Exponential. Number 13. Exponential. 14. Logarithmic. 15. Exponential. 16. Logarithmic. 17. Logarithmic. 18. Exponential. Number 19. Exponential. And finally, number 20. Okay, how easy was that? All right, so let's start solving these. Now, number 9. It says type 1 or type 2. What do y'all think? Type 1? Yeah, I agree. Type 2? Yeah, I agree. Couldn't I do number 9 either way? I absolutely could. Okay? Number 9, I could do either way. So let me show you. Type 1. Can I make 16 have a base of 4? What? 4 squared, right? But because it's in the denominator, to move it up, I make it what? Exactly. 4 to the negative 2 equals 4 to the 2x plus 4. Could I have done that? Absolutely, I could have. What do I get to do to solve this now? Cancel those 4s and take what's remaining and set them equal to each other. I would subtract 4, negative 2 minus 4, negative 6, and then divide by 2, so x would equal negative 3, right? Does everybody see that? But if I did type 2, could I do type 2 as well? Absolutely. Look at number 9. What is the base of your exponent? What's the base of your exponent?
16.
Nuh-uh. The base of your exponent.
4.
4. Make that the base of your log. Log base 4. And then do the loop. You just have to do the loop the opposite direction because equals is on the left now. So log base 4 of what? 1 over 16 equals what? 2x plus 4. Brayton, remember how to type in log base 4 of 1 over 16? You don't?
I got a question.
You better remember it. All right, what's your question?
How do you know if it's top 1 or top 2?
Number 9 could have been both.
Okay, now you know number 10.
Number 10, it's log equals log. So which one was log equals log?
I don't know. You gotta do that on the quiz?
Well, I mean, I don't know.
Question? Like,
Huh?
You gotta like circle that as an answer?
No, I don't think so. I haven't made the quiz yet. I don't think I'm going to put that part of it on there.
Yeah, I'll just keep it up for that.
I probably won't. But how do you know how to solve it? How would you know, though, how to solve that problem?
Because there's 2 logs.
There you go. So that's type 1.
Yeah, I just.
Yeah. Well, type 1 says log equals log. Type 2 says log equals a number. So here we go. If I typed in log base 4 of 1 over 16, that equals negative 2. And y'all notice something here? Aren't we in the exact same spot? So really, for that type of problem, if you can make your bases the same, you could technically use type 1 or type 2. Y'all understand? Now, anything else, there's no other option. You got to roll with the one it is. But if you can make your bases the same, you could actually go with type 1 or type 2. All right, so let's keep going. Number 10. Like Brayton said, I don't think I'm probably going to require you guys to tell me whether this is type 1 or type 2. That's really more for the review than it is for the quiz. So, it is type 1 of logarithmic equations because log equals a log, which allows us to do what? Drop them off. So we're left with 9x minus 4 equals x plus 20. How do we solve? Not all at once, please. I was having a hard time hearing everyone. Sarcasm. Huh? Subtract x. What's 9x minus x? So 8x minus 4 equals 20. Now to solve this, we're going to add 4. Divide by 8. X equals 3. Real simple, right? All right, let's keep on cruising. Number 11. This one's logarithmic. Is it type 1 or type 2? Yeah, for the review, we would call this type 2. Okay? It's not really like, this is not like officially type 2 of logarithms. This is just that's just for review purposes only. So this is definitely logarithmic, and you don't have log on both sides. Point is, we're going to solve by rewriting it as a what? As an exponent. What's the base of my log? What's the base of my log? 3. On number 11, what's the base of my log? 4. It becomes the base of my exponent. And then we do the loop. 4 to the third equals 5m plus 9. Are y'all okay with me just talking through these instead of asking the questions?
Yeah.
Okay, because I'm not getting a lot of answers, and I'm really only doing that for your purpose. So if y'all don't need it, I'm just gonna do them, okay? And y'all can stop me if you get tricked up. So 4 cubed equals 64. I'm gonna subtract 9. That's 55 equals 5m. I'm gonna divide by 5. So m equals 11. M equals 11. Number 12. Clearly, we already determined this is exponential. I cannot make 8 and 78 have the same base. Can't do it. It's impossible. So therefore, this has to be what we would call, in the review, type 2. Where you have to rewrite it as a logarithm. So, the base of my exponent, 8, becomes the base of my log. Log base 8, and then we do the loop. Log base 8 of 78 equals k. I'm going to bother you one more time, Brayton. Where do we go in the calculator to type this in? Nope. Alpha. Window. Number 5. If you don't, I'm telling you, if you ask me tomorrow, I might.
No video?
Well, no, because I whispered. I don't think it heard me.
I'm
So
gonna
you
look
can't
to see
prove
if
it.
I heard you.
You can't prove it. So 2.1 equals k. So this is just a character witness.
I put 2.09.
Yeah, I mean, it's fine. I'm not going to mark that wrong. But it's technically 2.095. So the 5 technically rounds the 9 up to a 10. So 2.1. But it's fine.
Or would it not be 2.0?
No. Because, look, if you type this in your calculator, don't you get 2.09513 like that?
Yes.
So if I'm rounded to 2 decimals here, this 5 rounds that up to a 10. So it would move it to this 2.1. Listen, I'm not going to get too worked up about y'all's rounding issues, but looks like some of us have some rounding issues.
No, I don't go around these.
I'll just play it. All right, keep on cruising. 13. Once again, this is exponential, and we have to use, for the review purposes, we have to use type 2. Why? I can't make 9 and 78 have the same base. So there's no way I can do type 1. So here I go. Rewrite it as a logarithm. The base of my exponent, 9, becomes the base of my log. And then we do the loop. Log base 9 of 78 equals n minus 6. I'm going to go to my calculator, alpha, window, 5. Log base 9 of 78 is approximately 1.98. And that equals n minus 6. I'm going to add 6, so 7.98 would be what I got when I rounded to 2 decimals. Please don't round up to whole numbers, all right, unless it's a whole number. Or it just can't help but round up. If that were 1.9996, well, okay. All right, 14, definitely logarithmic. I don't have log on both sides, so this is, for our review purposes, type 2. Log equals a number. So we rewrite it as a exponent. The base of my log, and this is the only trick to this problem, the base of my log becomes the base of my exponent. Well, what is my understood base of log? So it's 10 to the second power equals 4n plus 32. 10 squared is 100. To solve this, I'm going to subtract 32. That's 68. And then I'm going to divide by 4. That's 17. N equals 17. Questions about that one? All right, number 15. Exponential, we've already decided. It's not in the position to determine whether this is, for our review purposes, type 1 or 2, until I move this plus 7. Because remember, you're supposed to isolate your exponential part, and it's not yet. So I need to subtract that 7. So when I subtract that 7, I'm left with 15 to the 3a power equals 60. Can I make 15 and 60 have the same base? What could you have made it? Well, if it did 15, remember, Huh? No, because you can't just, remember, you just can't divide by 60 or 15. You either have to create.
I'm saying like 1/4.
What, 1/4 to what power would give me 60? Yeah, we can't. Because think about it. 15 is not a perfect square, right? And neither is 60. So nothing will even multiply to get those values. So I can't change them to have that same base. The point is, I got to rewrite this as a what? I got to rewrite this as a logarithm. So the base of my exponent, 15, becomes the base of my log. Then we do the loop. Log base 15 of 60 equals 3a. Alpha, window, number 5. Log base 15 of 60 gives me 1.51 is what I got. Last step, divide that by 3, and I got 0.5. 0.5. Yes, sir.
What was 13 and 14?
7.98 was 13,
Okay.
and 17.
Thank you.
Yes. Yes. All right, number 16 was logarithmic. And because you have log on both sides, for the review purposes, it's type 1, where you drop the logs. So this has got a little trick to it, because when you do that, you're left with one of your favorite types of problems, where you have to solve by what? Factoring. Remember, we can't just get m alone. So we got to get everything on one side. So I subtract that m, and then we solve by factoring. So we're going to factor into 2 binomials. To get m squared, that's m times m. To get this negative right here, that's a positive times a negative. So we're looking for the 2 numbers that multiply to get 12, have a difference of technically -1. It's got to be 3 and 4. And again, because minus wins the middle, you have to give minus to the bigger factor. Which one's bigger, 3 or 4? So it has to be -4. It has to be +3. Then, of course, we just take those, set them equal to 0, and m will equal -3, and m will equal +4. What time we got here? 2 minutes? I don't. I haven't done it. I haven't made it to this yet. Let me do it. Quizzes tomorrow. I will go over the last 4. In fact, I may just let y'all leave, and I may just make the video and post it. And I'll still go over tomorrow. I'm just going to keep the video going.
Is it gonna have an extraneous solution?
This is type 2, huh?
Is it gonna have an extraneous?
No, I won't have any extraneous tomorrow.
Okay.
So that's 2 to the 4th equals x squared minus 6x. So 2 to the 4th, sorry, okay, is 16. No.
I have to do this second.
All right. Okay. I'll remember.
No.
Move that over.
Oh, is us looking up gonna be on that video?
Yes. I'll pause the video. I'm gonna pause it and then finish.
That's gonna be so loud.
I'm pausing it. Okay, so I wanted to finish this up just for the video purpose. I did not finish this in class in 2nd, 3rd, 4th, and probably won't in 5th period. So I will finish it up in class as well. But let me go ahead, for the video purposes, finish this review. So for those who are watching it on their own, they can see the whole thing. So with this problem, like I talked about in some previous ones, because its log equals a number, we rewrote it as an exponent. And you can see the work there, 2 to the 4th power equals x squared minus 6x. Because there's an x squared and an x, I can't just solve for x, I've got to solve by factoring. So I've got it all the way down to this point. So remember, to multiply to get x squared, you've got x times x. To multiply to get negative, you've got positive and a negative. So we're looking for two numbers that multiply to get 16, but have a difference of 6. So that's 8 and 2. So last thing, since negative dominates the middle, negative has to go with my bigger factor, so that's the 8. And then 2 has to be positive. So if I take those now, and I'm just going to scroll up here to the top, if I take x plus 2 and set it equal to 0 and solve that, it's going to give me a negative 2. And if I take the x minus 8, set it equal to 0 and solve, it's going to give me a positive 8. So negative 2 and positive 8. All right? Number 18. Again, this one's definitely exponential. But like we talked about when we were solving these exponential equations, because there's so much around that exponential expression, 3 to the n minus 1, we can't really start thinking about solving this thing properly until we get that alone.
This is just a reminder, all senior teachers, please remember to pass out the senior superlatives.
So I'm going to add that 21. So I've got 8 times 3 to the n minus 1 power equals 51 plus 21 is 72. Then I'm going to divide by 8. So 3 to the n minus 1 power equals 9. And then honestly, hang on, let me get a calculator. This is the problem that could be solved using type 1 or type 2. Okay, you really have both options. And here's why. I can make 9 have a base of 3, 3 squared. Or I could rewrite this as a logarithm. Either way, you're going to come up with the answer. So I don't care which method you use. So let me just show you real quick both in case you're kind of stuck between two. I can either leave 3 to the n minus 1 and change 9 to 3 squared. So those bases will cancel and n minus 1 will equal 2. I can add 1, so n will equal a positive 3. Or at this very same place, I could have said, hey, I want to rewrite this as a logarithm. So the base of the exponent 3 becomes the base of the log. Then you do the loop. Log base 3 of 9 equals n minus 1. Well, log base 3 of 9, if you use alpha window number 5, is going to give you a 2. So 2 will equal n minus 1. We're going to add 1. So just like we did with the left side, we get 3. So this is one of those problems where you actually have both options. You could have done either type 1 or 2. Number 19. Again, very similar to the last problem, I got to get this exponential expression alone first. And to do that, I'm going to add 1. So 2 times 18 to the 10r minus 3 will equal 74. Then I'm going to divide by 2. So 18 to the 10r minus 3 power will equal 37. Then, of course, I look at this problem, and it's not the same as the last problem. Okay, I cannot take this and rewrite it using type 1 or type 2. I can't make 18 and 37 have the same base. So I only have one option here, type 2, and that is rewriting this as a logarithm. So log base 18 of 37 equals 10r minus 3. Again, I'm going to go to my calculator, alpha, window number 5, and do log base 18 of 37, and I'm going to get a decimal, looks like 1.25. And that equals 10r minus 3. So I'm going to add 3, so that's 4.25 equals 10r. And then I'm going to divide by 10. So 4.25 divided by 10 gives me 0.425. Or 0.43 if you want to round to 2 decimals. If you want to keep it consistent, 2 decimals, that would be 0.43. If you wanted to just keep it 0.425, that's fine as well. So there you have it. Okay, you only have that option, type 2. All right, and now, last one, definitely logarithmic. And I don't have logs on both sides. So this is type 2, where we rewrite it as an exponent. So the base of the log, 36, becomes the base of the exponent. Then we do the loop. 36 to the 1/2 will equal 20 minus 4p. So I'm going to type into my calculator 36 raised to the 1/2, and that gives me 6. So 6 equals 20 minus 4p. To solve this one, I need to move the 20 first by subtracting. So 6 minus 20 is going to be negative 14, and that equals negative 4p. So last step, I'm going to divide by negative 4. So negative 14 divided by negative 4 gives me approximately, well, 3.5. It ain't approximately. It gives me 3.5. So there it is, okay? We're solving exponential and logarithmic equations. I hope that you guys will study a little bit for this. We'll go over those last 4 questions, especially have any questions specifically about those. We'll spend a little time on them, and then we'll take our quiz. It's going to be about probably 14 questions on it. So have a good evening.